So the next thing we're going to take a look at in terms of pressure and gases is tools used to measure pressure. So what do we use to measure pressure? Very commonly used to measure pressure is a barometer. A barometer is used to measure atmospheric pressure, and usually it's in millimeters of mercury. Obviously, because in the United States here we have the English unit of measurement, it's commonly in inches. Inches per square, whatever it might be. So in millimeters of mercury, but again, a distance. And the reason that is because if we look at like an old school barometer, basically the idea is this, and again, they're not built like that anymore. They certainly are digital and whatnot, but basically what we have is this. We have a pool of mercury, okay, that has a open-ended tube that's submerged in it with a closed tube on the top. So on the top it's closed to the atmosphere, and on the bottom it's open. Now you can see here we have air pressure pushing down, okay, and obviously the mercury is in the tube. Now the more you push down, the more the tube of mercury is going to go up. And obviously that just makes sense. I mean, it's just displacement. As you push down on those sides with the air pressure, then you're going to have some, obviously that mercury has to go somewhere, it goes up. So you notice here we have 700, or excuse me, it says 76 centimeters, but that would be 760 millimeters of the mercury, and here we have 29.92 inches of mercury. So again, that's commonly what we might hear in the United States. So increase in pressure will make the barometer rise, okay, or the barometric pressure will rise, okay. Let's think about that, and you obviously hear that a lot of times. Meteorologists will talk about that. The barometer is at 29.92 and rising. Well, what does that mean? I think it's always a great way to determine if it's going to rain, if it's going to clear up. Think about your atmosphere, okay. If your atmosphere has a bunch of a bunch of molecules like oxygen, nitrogen, carbon dioxide, oxygen, carbon dioxide, oxygen, more nitrogen, you know, we're going to have some water, okay, as opposed to where it's a cloudy day. So clear day, cloudy. On a cloudy day, there's a lot more water molecules. There's still nitrogen and oxygen, carbon dioxide, but there's a lot more water. Okay? Well, obviously there's a certain limited amount of space. If there's more water, then some of those heavier molecules are pushed away. So take a look at the masses of these. Okay? Take a look at the masses. Oxygen, 32 grams per mole. Okay, nitrogen, 28. I'm just going to write 28. Carbon dioxide, 44. All right. When you look at water, it's 18 grams per mole. Okay. So which one of these, the clear day or the cloudy day, has heavier air? Well, there's heavier air on a clear day, because there's more of these heavier molecules. Because we have heavier air, then your pressure is higher, okay? Less pressure, because you have more of these lighter molecules on a cloudy day. So heavy air, increased pressure, barometer rises. So whenever you hear a meteorologist say the barometric pressure is 29.92 and rising, that means that it is clearing up. Okay? When you hear that the barometric pressure is falling, then watch out, we're going to have some rain or some precipitation. All right, so there's a barometer. The next type, and I'm going to clear this up and actually probably just talk about it on our next slide, but there's what a barometer is and how you use it.